Hi class, let's take a look at a problem that involves a little bit of gambling. And for any of the gambling problems, especially that they appear on the homework, you're probably going to be looking at the following formulas. And this is the ones on the last page, the one that I was actually highlighting. So I'll put them on the future exam 3 paper. But let's take a look at this actual example. So this is a roulette example, and the roulette problem, they're basically referring to the following. So they're going to toss a ball technically into the roulette, and then what you see here is the possible outcomes of the ones that you can bet. For any future problem, especially if it comes in the software, make sure you read it because they may change the sample space, but I'll keep the same sample space as the one that we have. Now, let's actually write the sample space on the side. So they're talking about a total of 38 values, but we're actually viewing it as follows. So this is equal to S, and the numbers out of the sample space, and I'm just writing it as a set because we're technically looking at the following values. Well, you can technically have, in terms of outcomes, numbers 1, 2, 3, and then all the way to the values of 36. That's the maximum. And then the roulette actually had, or the one that they're referring to in this case, actually has a 0 and then technically a 0, 0. So this is giving you 38 numbers, or actually outcomes. And then for this particular problem, they're saying that they put a bet on an odd number. So your odd numbers only qualified as these, and technically half of them are going to be odd. So 18 will actually be odd since that's half of 36. So the probability of winning, and let me just actually declare let A winning, or let A equal to bet on an odd number. Then the probability of A, well, your odds are technically 18 out of the actual total of 38. So 18 divided by 38, it's going to be approximately 47, actually, yeah, 0.47, and then 37, which is approximately 0.47. So we're talking about 18 divided by 38, which is actually giving us about 0.47. Now, for part B, they want the odds against winning. So they're not asking for the probability, but they want the odds against winning. And in this case, they want the following formula. Odds against the event is the event not occurring over the event occurring. So we're going to rewrite it as odds against the event. So odds against A this is equal to the probability of A not occurring over the probability of A. Let me just double check the formula again. It's not occurring over occurring. Okay, so the probability of not occurring, that means that the individual is going to lose. So they're going to lose if they come up with an even number or the zeros. So in this case, I'm referring as these two. So the chances of not winning, it's actually going to be any event, which is another 18 plus the other 2. So you're going to have 18 plus 2 over the total sample space, which is the values of 38, over the probability of winning, which is 18 divided by 38. So your fraction is going to look messy. This is 20 divided by 38 over 18 divided by the values of 38, which is going to simplify to 20 divided by, hold on, so this is a little bit messy. It's going to simplify to, so this is equivalent to 20 divided by 38 divided by 18 divided by 38, which is equal to which is equal to 20 divided by 38 times the values of 38 divided by 18. So this is going to give you, once you cancel the 38s, I'm ending with 20 divided by 18, which reduces to, if you divide it by 2s, I'm getting 10 nines. 9 times 2 is 18, and you're going to write it as 10 to 9 since they want it as odds. Oh, I can barely fit the formula. The last step. Now, if they want odds, you write it as this notation as A to B. And I'm referring to this notation as A to B. So we're looking at this A to B. There's no need to rewrite it as an actual decimal. Odds, you always express them as a fraction or the dot notation, which is the final answer that I'm circling. Okay, let's take a look at C. And in C, they want to find out the profit. So you're going to be using the following formula. And that's the formula that's here at the bottom. So you're using the odds equal to the net profit over the amount of the bet. So in this case, the formula that we're going to be using are going to be the payoff odds. So it's odds equal to, it was amount of the bet. So a net profit over the bet. So net profit over the amount of the bet. So in this case, this is a 1-to-1, and we want to know the net profit. And they're betting $18. So technically, if you multiply times 18 times 18, you're going to end up with 18 times 1 over 1 is equal to the net profit. So in this case, this actual game, if it's 1-to-1, it has a net profit of a total of $18. Now, you have to be careful because some of the problems on the homework, they're going to say how much would be the net profit and how much will be total return to you. Well, since you put in 18 and it's a 1-to-1 bet, they're going to give you $36 back. So they may ask that as a separate question kind of to trick us. So let me just write it here. So total money return this is equal to your $18 that you have plus another 18, so a total of $36. And they're not asking for that, but they could give you a problem where they're tricking you a little bit in this form. Net profit is 18, but they basically give you the profit of 18 and then your original $18. But it feels like you make 36, you only made 18. Okay, let's take a look at example 5. So some problems, they're going to give you a formula that they want you to evaluate. And they're a little bit tricky because they're going to give you, like in this case, cost is the name of the horse. They're giving you information about the race and other information that is not needed. Now, the only portion that you need here is basically the definition of, well, in this case, the odds. So this is technically always A to B, which means that A is equal to 97, B is equal to 3. So for this specific problem, the probability of A, and A is that the horse wins, it's going to be, well, you're going to have a 3 over 97 plus 3, or 3 over 100, or basically 0.03. And in this case, let A equal to the horse winning. So our main answer, it's 3 over 100 or 0.03. Some of these problems, they may want it as percentages. That would be sufficient if it doesn't mention anything about a percentage.